Hey folks, Ms. Gosling here. In this video, you are going to learn about graphing. By the end of this video, you will be able to analyze motion graphs for accelerating objects. So let's go ahead and get started. So let's start by talking about how we can tell if an object is accelerating. Now, we know that acceleration is the change in velocity over time, or acceleration is equal to delta v over delta t, which we could write a little more simply as v minus u over t final, which I'm going to call tf, minus t initial. So our final velocity minus our initial velocity divided by our final time minus our initial time. Looking at this graph, which measures velocity versus time, I'm guessing you can tell how we would figure out our object's acceleration. My initial velocity and initial time I can get by reading the x and y positions on my graph, and that's going to give me t initial equals 0 and u also equals 0 because my initial position, or my initial time, my initial x value is 0, and my y value at that point is also 0. I can do the same for my final velocity and my final time by looking at the last point on my graph. So my final time here, going down to the x-axis, is going to be 5 seconds, and my final velocity, going over to the y-axis, is going to be v equals 10 meters per second. So what I would get is that my acceleration is equal to my change in y value of my graph, my rise of the graph, divided by my change in the x value of my graph, or the run of my graph. So acceleration is equal to rise over run, or perhaps, as you might be more used to seeing it, slope. So if you have a velocity versus time graph, your acceleration is equal to the slope of your graph. One important thing to know here, if your velocity versus time graph is horizontal, so you've got a little graph that looks like this, or like this, or like this. I'm going to go ahead and get rid of those last two lines though. If you've got a horizontal line, our acceleration is 0. And that is, of course, for my velocity versus time graph. So I also want to leave you here with a slight extra credit opportunity. If you would like some credit for a missing assignment, go ahead and calculate the acceleration of this velocity versus time graph. And send me your calculations via email. Let me know if you decide to do that. So how can we tell if an object is accelerating if we don't have a velocity time graph? What if we have a position time graph? Let's talk about how we can figure out whether an object is accelerating. So we know that velocity is equal to slope of our position time graph, which I'm going to call x versus t. We also know that acceleration is equal to the slope of a velocity versus time graph. And we know that acceleration is equal to change in velocity over time. So how much our velocity is changing determines our acceleration. So knowing this, we know that if the slope of our x versus time graph, our position versus time graph is changing, that means that there is some kind of change in velocity, which means that we have some kind of acceleration. What does that look like? So think about a line, a graph with a constant slope. We could talk about a graph that looks like this. We could talk about a graph that looks like this. We could talk about a graph that looks like this. And they all have a constant slope. Let me go ahead, I'm going to replace this line a little bit. There we go. So you have three different graphs that all have constant slopes. And the thing that tells us that the slope is constant is if it is a straight line, so no curves. As soon as we have a line that isn't straight, we know the object is accelerating. So to summarize, for position versus time graph, if our graph is not a straight line, no matter what, we know that that object is accelerating in some way or another. And in the next few slides, we'll talk about what those ways are. And we'll start with talking about these first two graphs you can see here. So on the left, we've got graph number 1. On the right, we have graph number 2. And what I want to do is figure out whether we have a positive or negative velocity and a positive or negative acceleration. So let's start with velocity. So we know that our velocity is changing, but how do you find the slope of a graph that's curving? Well, there's a few things you can do. And the easiest thing to do is to actually draw lines that are tangent to the tangent to the graph at different points along your graph. And what I mean by that is draw lines that intersect with the graph at only one point along the graph. So what I'm going to do is I'm going to look at 3 points, 1, 2, and 3 along the graph. And I'm going to do the same with my second graph. And I'm going to go ahead and draw tangent lines for each of those. So we have our first tangent line. Okay, so I paused the video for a moment so I could draw in all of my tangent lines. And again, as you can see, to the best of my ability, these lines only intersect with our graph at each of those 3 points. So my first line on my first graph, you can see it's pretty horizontal. It's pretty flat. It looks like it's almost 0. Our second line is going uphill, so it's got a positive slope. And it's, medium fast, right? It's not steep, it's not shallow. This last one has a positive slope and is very steep. So what that means, first of all, we know all of our slopes are positive. And so that means that our velocity is positive. So if all of your tangent lines are going uphill, then you know that we have a positive velocity. So what I'm going to write is positive velocity because positive slope. Next, what I want to do is I want to figure out the acceleration here. So we're going from flat to a positive slope, kind of medium steep, to a very steep slope. So our slopes are increasing, our speed is increasing, and our velocity is increasing, right? Because we are moving farther away from, we're moving to larger velocities in the positive direction. And so what that means is that my object has a positive acceleration. Next, let's look at my next graph. So for this graph, we again start with a flat line. We have a line then with a negative slope and a line with, again, a negative slope. And for each of these graphs, we have, again, we're starting flat. Our slope is negative and kind of medium steep. And for the last one, our slope is negative and I would say very steep. So what this means is that our slopes are all negative, and because they are negative, that means velocity is negative, and that's because our slope is negative. Our acceleration is also negative. So we know that our acceleration is negative because my velocity is becoming increasingly more negative. So it's getting bigger in the negative direction. One way to think about this is if you have a velocity of -1 meters per second and an acceleration of, say, -1 meters per second squared, then in 1 second, making that makes our units line up, your velocity will go to -2 meters per second, which means that your velocity is more negative, your speed is larger, but your acceleration, again, is negative. So I just want to go ahead and leave that there. So acceleration because slope is getting more negative. Another way to think about this is that, a slope of, on the number line, -16 is a bigger number, but a bigger negative number than -8. So let's go ahead and move to 2 more graphs. And again, I'm going to pause the video for a moment so I can go ahead and draw in my tangent lines at 1, 2, 3 points. And I'm picking 3 points that are equidistant. It really doesn't matter which points you pick. Okay, so again, I've gone in and I have drawn my tangent lines at each point on my graph. So let's look at my first graph on the left. And we're going to start by characterizing whether our slopes are positive or negative. So looking at all of my slopes, I know that they're all going uphill. And so that means that my slope is positive. So positive slope, positive slope, positive slope. And we're going to go ahead and say that zero slope is about positive too. So all my slopes are positive, so that means that my velocity is positive. What about my acceleration? So looking at my 3 lines, I can tell that my first line is the steepest, and my last line is the least steep. So that means that my object is starting to move more slowly. And what that means, and we also can tell that my velocity is getting less positive because my velocity is decreasing because my slopes are decreasing in their steepness. So because of that, I know that my acceleration is negative. Let's look at my second graph now. So my second graph, my object is starting out and it's going downhill with my slope. So that means that my slope is negative. And the same is true at all 3 points on my graph. So because all of my slopes are negative, all of my slopes are downhill, I know that my velocity is also negative. Now let's look at my accelerations. So my first graph, the first part of my graph is the steepest. And the last part of my graph is the least steep. So I'm guessing what you're saying is, oh, this means that my acceleration must be negative because that's what happened in the last one. But that is not the case. So remember, when we add a positive number to a negative number, that number is going to decrease in magnitude. So for example, negative 16 plus negative 8 is equal to, negative 16 plus 8 is equal to negative 8. So my velocity here, my slope, is decreasing in magnitude or in number while remaining negative, which means that what I have to be doing is adding some positive number to it. So that means that my acceleration has to be positive. So whenever we have a slope that's decreasing, that means that my velocity and acceleration have opposite signs. So if you can figure out the sign of your acceleration and you know that your slope is decreasing, you know that your acceleration sign, if you figure out the slope of the sign of your velocity, and you know that your slope is decreasing, you know that your acceleration has the opposite sign. So if you have a positive velocity, you know your acceleration must be negative, and vice versa. So let's go ahead and go to our takeaways. So if a position versus time graph is not a straight line, then the object is accelerating. Similarly, if a velocity versus time graph is not a horizontal line, then the object is accelerating. And you can use the shape of a graph to determine whether the acceleration is positive or negative. So there you have it, guys. This has been your graphing with acceleration topic. It is your turn now to go ahead and give it a try on your own. Best of luck and happy solving.